Hello everyone, I hope that you're doing well today. Let's talk about multiple regression. Now, regression is something when you have to predict something, predict your outcome based on some predictors or based on some IVs, independent variables. For multiple regression, you need to have a specified DV, dependent variable, and your IVs or IVs, independent variable or independent variables. Let's say I have some variables over here. This OST, ostracism, AAQ is psychological inflexibility, WHO is well-being, MLQ is meaning in life, CPC is compound psychological capital, GD is depression, and PW is psychological well-being, and BE is belongingness. All you have to do is go for the analyze, come towards the regression, and go to the linear regression. Now, if your DV is specified, just enter the DV over there and see which variable you want to use as an IV. If you have one IV and one DV, all you can do is you just need to have a simple linear regression. You cannot go for anything else. So go for statistics. You need constant interval, you need descriptives, you need residual for Dublin Watson. Click on continue and click on OK. So there you have it. This is the complete regression. It's telling you about the mean and standard deviation. In the second table, is telling you about the correlation, that the depression and the belongingness, they have a negative correlation. Over here, if you see the model summary, the R, this R is almost equal to this R, the correlation that you found over here. So this is basically the correlation R. R square is something that your IV is causing this much percentage of variance in your DV. All you have to do is, this is 0.114, all you have to do is whatever the value is over here, you have to multiply it by 100 to convert it into the percentage. So the percentage would be 11.4%. This means that belongingness is causing or explaining 11.4% variance in the depression scores. If you go for towards the ANOVA, the value is significant. F value is 31.21 and the values are significant. The model is significant. There are two more things, unstandardized beta and standardized beta. You have to report all three as per the APA7 table. The unstandardized beta, standard error, and standardized beta as well. Now this is negative. The slope is negative, which means that IV is negatively predicting your DV. Over here, IV is belongingness, so belongingness is negatively predicting the depression, which means a person who feels belonged in the community, he or she will be having less score on depression scale. These are the lower bounds and upper bounds. Now let's go towards the table and see what kind of table you can create for the simple linear regression. You see over here, we can just change the table, and all you have to do is write simple linear regression. And over here, we are going to write belongingness. Now, as per the APA7, this thing has gone down to the nodes. So you need to write it over here. We have sample size of 260. We're going to write 260 over here. Let's see what more changes do we need to do over here. The step 1 will go. And all the other columns, they will also go. This will be used in multiple linear regression or multiple stepwise or hierarchical regression. Now you have this. Just let me adjust the table for you. There we have it. Belongingness. I need to write you values from here. The constant value is 12.04. So in APA, you have to round off the values to 2 points only after the decimal. Standard error is lower bound is 10.02, 10.03 in this case, because if you round it off, it becomes 10.03. And the upper limit is 14.06. Standard error of beta is, this is standard error of beta 1.02. And your beta is, for the constant you do not have the beta. So you have to skip this one as it is. For the R square, you have to go up. This is your R square, 0.114. You can write 0.11, and for adjusted R square, this is your adjusted R square, you can write again 0.11. So there is no much difference. Over here, the difference is at the third point, but when you round it off to 2 points only, it becomes the same. So you do not have to worry about it. Activate the lower border, write the values for belongingness. Minus 0.8 if you round this off. Lower limit is minus 0.11. And the upper limit is minus 0.05. Standard error is 0.01. And the beta is minus 0.384. For this, you are not going to write your R square and adjusted R square. So this is done, and you have to write your interpretation over here. Simple linear regression is performed to assess the variance in depression predicted by belongingness. Over here, we're going to write overall model is significant, explains. Now, coming towards the R square, it only explains 11% variance in depression. F is go there. Over here, you have DF for regression and S dual 1 and 2 for 2. So you have to write over here 1, 2 for 2. Write the value of ANOVA over here, 31.21, and your p-value is less than 0.001. Belongingness. So we are going to mention the standardized beta over here. This is minus ostracism, no, it's belongingness. Belongingness beta is minus 0.34. You put 3 static over here because the value that we are getting is 0.001. If you want to shorten your table, you have to erase the 1 star and 2 star, and all you have to do is write 3 star over here. And for these stars, select these stars, go over there for the superscript and press this one, the stars become smaller. was a significant negative predictor. That's it of depression. So this is single simple line that you have to use for a simple linear regression over here. The sample size goes at the down as per the APA7, and this is the interpretation. So you can pause the video, take a screenshot if you want, that would be done. So let's move towards other analysis, multiple linear regression, and then the stepwise and hierarchical regression. Let's try for multiple regression now. You have to go for analyze, regression, linear regression, all the other things will remain the same. Look over here, estimates, confidence interval, model fit, R-square change. This time you're going to put this one, descriptives, Dublin Watson. Let's continue and put your more IVs over here, because for multiple regression you need to have multiple IVs. So let's say I am including all these: ostracism, psychological inflexibility, psychological capital, well-being. Remove this one, this is well-being, it cannot be an IV. Meaning in life, and you need to press OK. Now for multiple, this is multiple linear regression. This will give you only one model because it's not generating any other model. It's going to explain that all the 4 or 5 variables are 4 or 5 IVs combined, how much variance they are predicting in your model. This again R square 0.365. So if you multiply it by 100, it becomes 36.5%. So it means that these variables 1, 2, 3, 4, 5, psychological capital, psychological inflexibility, meaning in life, ostracism, and belongingness, they are producing or explaining 36.5% variance combined in your depression scores. The model is significant. Over here, if you look, the significance value is 0.000, so these values are significant. Now the betas are different for over here, and all you have to do is you have to just draw your table as I showed you, and in that you will be having more values this time, like the ostracism, AAQ, MLQ, and CPC. Let's go for multiple stepwise regression. So you have to go again for regression, linear, and this time you need to go for stepwise. Over here in the method section, you need to go for stepwise. Now stepwise is done when you are not sure which variable would be a strongest predictor. So you let the software decide for you that which value, which IV will be the strongest predictor, which becomes at the second point, which comes at the third point. Press OK. Now you will be having multiple models instead of just one. We got 3 models, which means our strongest predictor is AAQ, psychological inflexibility. On the second one, we have psychological capital, and on the third, we have ostracism. These are the significant values. These are the R's. These are R square are the combined or cumulative variance. Cumulative or combined means if you look at model 3, this says 0.351. So this means the 35% variance is being explained by all the 3 variables combined: psychological inflexibility, psychological capital, and ostracism. But if you look at the R-square change only tells you about a single variable. For example, if you look at it over here, 0.017, it means that only 1.7% variance is being explained by the ostracism, because ostracism is the thing that was added in model 3. C is model 3. It was added over here. Over here, it was not added. Go for the ANOVA. Look, the values are significant. Your coefficients are significant. All you have to do is write static if you're 1 static, if your beta is significant as 0.05, like this one, 0.014. So it's lower than 0.05, but it's above 0.01. If it's significant at 0.000, you write three stars as per this, and you write 2 stars if it's 0.001, 0.005, 0.007. Because it's lower than 0.01, but it's above 0.001. It's telling you which variables were excluded in Model 1, in Model 2, and Model 3. Now let's go for hierarchical regression. In hierarchical regression, you have multiple highways, but you need to create your blocks for the analysis to run. Why you need to create the blocks? Because you are going to generate, or you are going to decide or control the variables, at which variable you want to put in the Model 1, which variable you want to put in the Model 2, and which variable you want in the Model 3. So let's try this one. If we go over here, then let's say for first predictor, I'm going to put ostracism. For the next predictor, I'm going to put psychological inflexibility. For third, it could be psychological capital, and the fourth, it could be meaning in life. The rest of the things, they remain the same. You press continue and you press OK. Now, as you can see, I wanted 4 models. It gave me 4 models. Although the 4th model is not significant, but still it gave me the model because I requested it to be. Look over here. The 4th one, the MLQ, as soon as it comes, the value becomes not significant. So these are the values that you are going to write, and how you're going to write it in the table is, look over here, hierarchical regression. Now this sample size go at the down in the note section. And it becomes 260. Now, since I have also added for demographic variables, what we're going to do, I'm going to run the analysis again to show you by putting the demographic variables over there. The purpose of demographic variables is to, if you want to control, if you want to see that apart from the demographic variables, what kind of change is being there. So even if you want to take a screenshot right now, let me scroll it down again and you can take a screenshot for your further processing. This is the APA table, hierarchical regression. And if you go down in step 2, the first variable is entered. In step 3, second variable is entered. And in step 4, a third variable is also entered. So this is your choice. Let's try the analysis as per this. Go for regression, linear. I'm just going to remove my blocks. There you go. So let's try age, profession, living status, residence, education, marital status, or children residence, whatever you want as your demographic or even the gender. Just put it over here. In the second block, you go for the main predictor now. Let's say it's the ostracism. Over here is the psychological inflexibility, and then you go for next again and you put CPC. You press enter and you have multiple models over here, and you just need to explain what kind of models you created. Now you can see there are 3 steps, 3 models that were being generated, and you have to write the interpretation as per this only. Now, while doing this, just remember one thing. In the interpretation section in the table, you have to, if you are moving towards step 2, you have to write about all the variables again, put it over here, and over here the values, they will be coming from this step 2 now. This model 2 is step 2. They will be coming from here now. And in step 3, the values of the demographic variables, gender, marital status, all they will be coming from step 3, model 3 over here now. These values that you need to put. So over here, as you can see, the values they are being changed. If the gender was in step 1.81, now in step 2 is 0.60. In step 3, it's again 0.84. So they keep changing. So you do not have to worry about it. All you need to do is put the values as per your output. You can take a screenshot again. Now the regression is same. And there's just one line for people who want to go for further analysis like the mediation. You need to add this line over here. The result shows that once you put your extra IV, the value of the previous IV, the beta value, it changes from or decreases to or increases from X value to Y value. Over here it was 0.45 to 0.32. So you need to write it down as this, and you can say that these variables can be used as mediators which can be tested in further analysis. So that would be all for multiple regression.